Assalamualaikum and hello, my name is Nur Ali Shafiqah binti Anwar. My metric number 8182718. Instruction. First, liter per 100 km. In this data collections, there depends variation in the liter per 100 kilometers because an equipment may be used to determine how much fuel the car uses every 100 km. This is continuous qualitative variable. Second, travel distance in kilometer per liters. In the data collection, travel distance is an independent variable. This qualitative variable is continuous. 3. Cylinder. In this data collection, the cylinder is independent variable. Given that in the simple to count the number is cylinder in each car, this is a district's qualitative quality. Next, horsepower. Horsepower is an independent variable in the data set. This is continuous quantitative variable because a car performance can be ranked by the car horsepower kW. Weight. In this data collection, weight is independent variable. Since weight can only measurable by employing equipment, this is a continuous quantitative variable.
My name is Amir Rahman bin Osman Zabbar. My metric number is A210391. We talk part 2. I want to talk about sampling data and record data category. First of all, I took the data from eCampus. To open data, I used SPSS application and found out the AFT2103 sample of the data for set A. So I changed the data sample to 153 since the lowest two-digit number of our member is 03, which is Nur Ashikin binti Azman. So now our sample is 153. After that, I record the data. The record is liter per 100 kpi and the horsepower. Here, the sample of the record. Next, I will pass to my friend to explain about descriptive measure. That's all. Thank you.
Hi, my name is Farisha AFT2103 and my metric number is A21A2746. So, I want to talk about graphical representation that I work with Mr. Amirul. First of all, we do frequency polygon based on the data that my friend calculate. Frequency polygon need class, frequency and midpoint. As we can see, the higher frequency is 39, so we can look more at graph that I draw with my hand. The graph shows ascending and descending. The midpoint 5.78 shows the higher frequency of 46. The lowest frequency is 1 at the midpoint 10.38. Last but not least, the second graph is histogram. Here is histogram table. Also, we can see the highest frequency is 85. Let's see on the graph. Based on the graph, it is clear that at midpoint 14.995 is the higher frequency of 85, while at the midpoint 30.995 it is the lower frequency of 2. You can see the big difference between the two numbers. So, I pass to the next presenter, which is also my friend. I'm done my part. Thank you.
Okay, hi, my name is Nur Nabila binti Nur Hisham. My metric number is A21A3005. Okay, my part is I will explain about the numerical descriptive measure. A measure of central tendency is a value that represents the center of distribution. Three most used measure a tendency for ungrouped and group data are mean, medium, and mode. Measure of central tendency in the grouping data. Okay, we have two focus. One is liter per 100, fuel consumption per 100 km for 152 observation, and the travel distance in km per liter for 152 observation group data. Okay, the frequency distribution for two focus is same. That's the number of classes. The number of class is 9, which is 2 power 9 equal to 1512 and greater than 393. Okay, class width price for the liter per 100 is maximum entry minus minimum entry divided by number of classes. So the calculation 11.11 minus 3.26 divided by 9. So the calculation is 0.8722. While the travel distance we have 30.7 minus 9.00 divided by 9. So the calculation is 2.41. Okay, next is the measure of central tendency. So that's mean, median, and mode. Okay, the liter per hundred, mean is 6.3001, median is 6.2191, and also mode is 6.0231. For the travel distance, mean 16.39, median 15.7715, and mode is 14.3602. Okay, for measure of variation, the calculation of range first is maximum data entry minus minimum data entry. So for liter per hundred, the range is 11.11 minus 3.26. So the calculation is 7.85. For the travel distance, the range is 30.7 minus 9.0. So the calculation is 21.7. The sample variation for the liter per hundred, sample variance 1.0143 and sample standard deviation 1.0071. For the travel distance, sample variance 9.3034 and the sample standard deviation 3.0502. Okay, next, for measure of position, the calculation of quartile. For the liter per hundred, quarter 1 calculation is 38 and quarter 3 the calculation is 114. So quarter 1 the calculation is 6.3948 and quarter 3 8.2014. So the quarter rate, quarter 3 minus quarter 1, 8.2014 minus 6.3948. So the calculation is 1.8066. Okay, next for the travel distance. Quarter 1 the calculation is 38 and the quarter 3 the calculation is 114. So the value of quarter 1 is 15.5832 and quarter 3 is 18.2582. So the interquarter rate is quarter 3 minus quarter 1. So 18.2582 minus 15.5832. The calculation is 2.6750. So that's all from me. Thank you.
5.0 Statistic Analysis Using Software, and this is the timetable for 5.1, which is Numerical Descriptive Measure. Next, we move to comparison between Numerical Descriptive Measure Manual vs SPSS. The first one is measure of central tendency for liter per 100, full consumption per 100 km for 152 observation. The timetable show the mean, median, and mode for manual and using SPSS software. Next, the timetable show for travel distance in kilometer per liter for 152 observation using group data. The description that we can express is mean, mode, and median between manual way and SPSS way. For all column is almost same. The answer has a bit different in terms of decimal value after round off the answer. Third, the measure of variation. The first table shows about liter per 100 full consumption per 100 km for 152 observation. The table said about variance and standard deviation for manual and SPSS software. The second one for measure of variation is travel distance in kilometer per liter for 152 observation in group data. The description that we can say is variance and standard deviation for manual way and SPSS are almost same. The decimal point value has been round off. Next, this is the graph using software, which is SPSS. Okay, the frequency polygon for liter per 100, full consumption per liter kilometer for 152 observation. The graph is here, which is the mean is 6.3828. Standard deviation is 1.3423 and the n is 150. The next one is graph for histogram for travel distance in kilometer per liter for 152 observation. The slide show two graphs, which is using manual way and SPSS software. For frequency polygon for liter per 100, full consumption per 100 km for 152 observation. Okay, the graph or SPSS is using ungroup data and it is generated with x-axis for liter per 100 and y-axis for frequency. The second one shows histogram for travel distance in kilometer per liter for 152 observation group data. Okay, the graph shows the x-axis and y-axis as the same as the drawn graph, and both graph shape is symmetric. 5.2 is hypothesis testing. The timetable show for hypothesis testing. The explanation that we can say is there are many various categories on the table, such as liter per 100, kpl, cylinder, horsepower, and weight. The df for all categories remain unchanged, which is at 149. The table shows about liter per 100 fuel consumption and also the travel distance in kilometer per liter using group data. The next one is we show about the how to calculate using one by one the step. The first step is we use null hypothesis versus alternate hypothesis. Okay, the second step is we use the significant level which is A at 0.09, and after that the step 3 we use the test statistic. After we calculate the answer, then the step 4 is we need to reject or not. After step 4, the last step is we make the decision and we conclude the calculation on the table. Next, the table shows about the ANOVA. The last one for 5.2 is factor, which is urban. The urban also has the step from step 1 to step 5, and the first step is we use the formula. The step 2 also use the significant level A at 0.05. Step 3 also same, we use the test statistic and make the calculation. Step 4 is we make the decision rule, which is we need to reject or not, and the step 5 also we need to conclude the calculation.
5.3 Correlation Analysis. Correlation is statistical technique used to determine the degree which is 6 variables are related. From the above table, the liter per 100 correlation is 1.0, so the strength of the relationship between liter per 100 and KPI is moderate. The nature of the correlation is negative. Next, the relationship is significant because the p-value is less than 0.5. 5.4 Correlation Interval. We had analyzed for the sales variable using the urban factor. Urban factor have two levels, which is liter per 100 and KPI. For liter per 100, the lower boundary and upper boundary are 30 and 143 respectively. The standard error for the dependent is 11.0 for yes level, the lower boundary and upper boundary 1.43 and 16 respectively. The standard error for the yes factor is 28.01. 5.5 Prediction Modeling. In the scalar plot metric, graph 1, plot liter per 100 against income. There is a moderate positive correlation between liter per 100 and KPI. Graph 2, plot liter per 100 against population. Is it seen that the higher the population, there is a moderate positive correlation between liter per 100 and KPI. Graph 3 plots KPI and population. There is a weak positive correlation between liter per 100 and KPI. Conclusion: with 152 observations, the data set visual views consumptive per 100 kilometers is provided to us. Several variables with the title liters per 100, travel distance, cycle, horsepower, weights, and brands are listed in the data. A few sections including data, description, sample data, numerical description, measurable, unmeasurable of center tendency, unmeasurable of variation, unmeasurable of positive, unmeasurable positions, graphic representation, and statistic analysis using software must be complete utilizing the data. The number of classes inverse of weights, class bounds, relative variance distributions, and cumulative reflection distribution, we all determine it using a frequency distribution to create the supply data set.